Okay, Bismillahirrahmanirrahim. Okay, folks, welcome. You can't see them over there, is there? Okay. Welcome back. We look with our little SATS class. We're doing test B today, Science 2012 QCA original paper. Okay, without any further delay, let's move on. Okay, right, here we go. Let's move up a bit. Okay, can we see on number 1 is pond life, yeah? I need to move the page a little bit up a bit so we can see the full question. Okay, here we go. Question number 1A. Right, let's grab ourselves a pen. Right, on this pen. Tom is finding out about pond life. He holds a glass bowl in the water and watches the pond life underneath. What property of the bowl allows Tom to see the pond life? So the glass bowl is
see-through.
Okay, see-through is correct. You can get that as an answer.
What was it?
But what's the? We can also say what?
Clear.
Clear. What else?
Is the science
Transparent. Transparent.
Jinx.
Transparent, right? It looks like transparent.
That's what I said. Transparent.
Okay.
Transparent.
Okay. Right. So the glass bowl is transparent. I was just checking that one. That's the spelling. So yes, transparent does have parent in it. Now, what else did we say was the possible answer? Some of you said it was? Okay, yeah, you can also write down see-through. That will also give you an answer. Okay, what else could you have written now? You said someone said it is?
Clear.
Clear. But the scientific word is?
Transparent.
Transparent. Let me use that word. That's better. Question B now, 1B. The picture below shows some of the things Tom sees underneath the bowl. Water beetle, stickleback fish, pondweed. The stickleback fish is a predator. Okay, tick one box to show why the stickleback fish is a predator. Okay, let's have Mr. Kamal. It eats other animals is absolutely correct. So it goes tick one box and that's the right box. Let's move on. Okay, now, so let's move the page down a little bit. Okay, next one. The pondweed is a producer. So write true or false next to each of the following statements about producers. So we've talked about predators. Now we're talking about producers. So here's the key word here. So producers are at the start of the food chain. True or false?
False. True.
What? Give me an example of a producer. Pondweed, grassy stuff, green things, plants, grass, yeah, things.
Seaweed.
Yeah, seaweed, yeah, leaves, yeah, for example, yeah. Next, producers catch their food from the water. Is that true or false? Well done. False. Okay, next one. Producers use sunlight to make new materials for growth. The answer is? True. What do we call this process? Does anybody know the special name for this process of capturing sunlight and turning it into food? It's called photosynthesis. No, photographs where you take with the camera. Photosynthesis. Okay, let's look at question D. We have Tom here. Here's Tom. Okay, give me a moment. Okay, D. Tom says microorganisms are living in the pond water. Explain why Tom cannot see the microorganisms in the water. Okay, that's a very easy answer.
Because they're too small.
Because the microorganisms are too small. You say here. So the microorganisms are too small with an extra O. Yeah, two indicating lots of what? Lots of smallness. Okay, full stop then please. So the microorganisms are too small for us to see. Oh, you need a microscope. Part 2 now. Why does it help to have why does it help to have some microorganism living in the pond? So what is the purpose of the what are they doing there? Why are they there? What is their purpose? For eating is close. It's to do with their type of eating. What do they do?
For developing food.
Mm,
Eating all the dirt.
okay, it's close. What do they do with all the waste that's in the water? They
They
break it down. Okay, so they are used to recycle the waste into nutrients, number one, or they break down the waste. Okay, so the microorganism they
break down the waste.
they they break down
The waste.
and they change into what?
Turned it.
Into nutrients for other creatures to have. Break down the waste into nutrients. So, for example, we have, like when you have a what was I saying? Like for example, when leaves fall and they on the floor, then you have like microorganisms that break the leaf down, and the nutrients that come out of the leaf go into the ground, and the plant uses the other plants use them to grow. Breaks it down into small molecules. We have microorganisms in our stomach. In your stomach, you have microorganisms which break down your food from chips or beans into proteins and everything else what that contains and sugars and things.
They put it inside where you can put it into the digestive.
Okay. So without microorganisms living inside your gut, your intestines, you couldn't actually break that food. The food wouldn't do anything for you. Microorganisms break down for example, everything that you eat and drink and take all the strips it down all into small molecules. Then your body absorbs those molecules, protein molecules and fat molecules.
So like small bits.
It's so small that you can't even see it. That's what your body actually needs. So the microorganisms break down all the food into those really small little.
Like tiny cat food.
Yeah, even smaller than that.
Food, I mean.
Question number 2. Paul hits a triangle with a metal rod.
That's gonna hurt the triangle.
Okay, what do we say?
Pardon me. Pardon me.
Okay, Ilyas, what do we say? He sneezed. Ilyas, what do we say when you sneeze?
Alhamdulillah.
And what do we say in reply? Yarhamakallah. Allah yahdik. Okay, right. Yeah, Doctor the back, Mr. Kamal. Yeah. Question 2, triangles. Paul hits a triangle with a metal rod. The triangle makes a sound. Here's the metal rod, here's the triangle. What happens to the triangle for Paul to hear a sound when it is hit? What happens to the triangle? The triangle is what? Put your hand up. Okay, let's have Mr. Rion. Give me the scientific name for what has to happen for a sound to be heard. So what is the metal doing? The metal is?
Tapping.
No, when you hit the triangle, what happens to the triangle for the noise? Well done. So we can say that the triangle vibrates. Or we can write down just vibrates.
The triangle vibrates.
The size of a triangle affects how high or low the sound is. Paul has 4 triangles. Write the letters A, B, C, and D in order to order the sound the triangle makes from the highest to the lowest.
Oh, I know the order.
Okay, Mr. Rion, go for it. So what will make the like a high noise, high note?
No.
No.
Oh. C.
C. The smaller the triangle, the higher.
Yes, the note.
That's right.
Yeah, no.
Okay, so the first one is
C.
C, and then
B. No, A.
A, and then
B.
and then
D. I mean D.
okay, lovely. C, A, B, D.
A.
Now, question C: what scientific term is used to describe how high or low a sound is? So if you want to describe the high tone and the low sound, what would we use? What would be the word that we use? It rhymes with something that you play football on. Actually, it's the name, same thing. What do you play football on? Pitch. That's right.
Pitch. Football pitch though.
There you go.
Then the pitch of sound.
There you go. So the word pitch tells you how loud or low the sound is. Okay.
Next pitch.
Right. What else could be an answer for this? For part C, we could also write down frequency. That's also an acceptable answer, but the main word here is pitch. Okay, lovely. Let's move on to the next question. Okay, right. We are doing a science paper now. Okay, Paul takes one triangle. He investigates how the volume of the sound changes when he hits the triangle with different amounts of force. He uses a sound sensor to measure the volume. He repeats his test 3 times for each force. So, we have to now use these words here. These words in here. So let's look. We've got 12, 15, 14, 8, 10, 6, 16, 19, 21. Which one had the loudest sound? Which one? The first, second, and third one? Third one. So which one should we use for the third one then?
White. No, very hard.
That was the loudest.
Very, very hard.
No, please, we don't write down very, very hard because that's not an answer there. You can't make up your own answers.
Very, very hard.
Okay. So very hard is being used. Which one had the next in terms of loudness? The first one is there. So the first one, what are we going to use for that one then?
Smooth. I mean, quite hard. Quite hard.
Okay, it's not crit will have no evens. And the next one, which is the lowest volume, that would be the
Gently.
and that's all of them three used. Because gently had the lowest sound, the lowest, and the next one was the 12, 15, 14, the next kind of level of sound volume higher, but not the highest. The highest was very hard, 16, 19, and 21. Explain why Paul repeats his test 3 times for each force. Why is he repeating the test? Put your hands up, please.
Don't know. To check if his calculations were right.
Correct. To check if his measurements were reliable, to get an average, to get more evidence, to make his results more reliable. But what Qasim just said there, that's a fantastic answer. So let's write that down. So to check if his results are correct or reliable. That's it. That's just one wording. We could write down to get an average result. We could also write down to get more evidence. We could also write down to make his results test more reliable. So different wordings meaning the same thing. Okay. Okay? Happy? Question F. Paul hit the triangle gently 3 times. The volume was not the same each time. Explain why the volume was not the same each time. Okay, let's have Zainab.
Oh, he must have done it a bit harder.
So Paul may have hit the triangle harder on different. So it's difficult for him to make the hits the same. Same. So it is hard to hit the triangle exactly the same force each time. Let's write that down. Okay, should we move it down a bit, the page a little bit, so we get some extra space?
So,
Okay, go on.
force against hurt.
Okay, give me one moment, please. So what do we say? You said here 8 is hard to hit the triangle.
Hit the triangle.
To hit the triangle with exactly the same force each time. Full stop each time. Okay, are we happy with that?
Yes.
Okay, lovely. Let's move on. Let's move up a bit. So the next question number 3. So we should all know why we repeat experiments. We always repeat experiments to get a more reliable results, to check the results, to get an average. All those kind of wordings are good. The next question number 3 is talking about dandelion. Okay, so class 5 went to compare dandelions growing in short grass and dandelions growing in long grass. They collect 20 dandelions from each place. They measure the length of the dandelion stems. Okay, this table shows the number of stems at each length in short grass and long grass. So they've ordered it for us by length. Okay, length of grass, short grass and long grass. It says tick one box to show the most common length of dandelion stems in long grass. In long grass, which is the most common? Come on, folks. So what we're doing here, we are looking over here at long grass, and we're looking for the which was the which box? Oh, sorry, which is the most common length?
The thingy 7.
Okay, you got 0 length, 1 centimeter, 6 centimeters, 11.
11.
Sorry, no, pardon me. 3 to 6 centimeters happened 0 times. 7 to 10 centimeters happened once. 11 to 14 centimeters, you had 6 of them between. 15 to 18. Well done. Why? Because how many were in there?
11.
Okay, 11 of them went there. So this one here, 15 to 18, had the highest number of dandelion in that group. So the answer will be here, will be 15 to 18. 15 to 18. Next. In the table, how many dandelions had stems of 15 centimeters longer? So I'm going to need to move it up a bit. So it was 15 centimeters or longer. So, right. No, I get to find them. Okay, 15 centimeters longer is this one here. So we have to look at these 4 values here. If we add up those 4 values, what do we get? 13. Well done. Excellent. So we have 13 dandelions which are 15 centimeters or more. So 0 add 0 is 0, add 2 is 2, 2 add 11 is 13. Done. Are we happy with that question? Yes? Okay, right.
Mark, can we make it a bit quicker? Why?
Question part 3, number 3. Before the test, the children made some predictions about the dandelions in short and long grass. Tick one box in each row to show whether each prediction is supported by the evidence from the table of results. So, where dandelions grow makes a difference to the stem length. Supported by the evidence, yes or no?
I don't know.
Yes or no?
Yes.
Yes.
Oh, yes. What a guess. I said.
Okay, there will be more dandelions in the short grass than in the long grass.
False.
Hold on.
What a guess.
I will quickly go back and have a look at that. So from the short grass, so we had 4 over here, 12 and 4. So we had all the information. They were short. We had smaller ones, smaller length. And in the long grass, we had longer lengths. Okay. So let's go back to the text. Where dandelions grow makes a difference to stem. Yes, it does. There will be more dandelions. We didn't find more because what did they do? If you look at the experiment originally, they took 20 dandelions from each place. So the experiment doesn't show that. They took 20 from each place. Okay, ready?
Oh, yeah, ready?
Okay, let's move on. Dandelion stems need to be longer than the grass they grow in to help the seeds disperse. Look at the picture of the dandelion seed. Dandelion seed, and then you have this kind of umbrella bit over here at the top. How is the dandelion seed usually dispersed? So how does the dandelion seed get away from where it is, from the plant? How does it get away? Disperse, it flies away. So what? So we say it flies away. What's causing it to fly away?
The wind.
That's right. So it's dispersed by the wind.
Yeah, the wind on the box.
Okay, you can say by air as well, or it is blown, the seeds float away. But the wind is nice and good.
By the wind.
The wind. So the wind is used to disperse some water. Okay, next question. I think we definitely need to move the page up a bit because we've got some options we can't see. Take one box to show which life seed dispersal is part of a life process of the dandelion plant.
Reproduction.
Remember Mrs. Neg? Movement, reproduction, sensitivity, nutrition, excretion, respiration, and growth. Mrs. Neg. Mrs. Neg.
No, like
Give us the necessary use to memorize those points.
reproduction.
Okay, so this one is help us for.
Reproduction.
Well done. Because it's order for the seed to go away and start growing again. It's like a new plant to start growing. Okay, next. Question number 4, identifying solids. Mia has 4 different solids. Her teacher asked her to find out what the solids are. So Mia mixes a teaspoon of each solid into different beakers of water. She records observations, table 1. Okay, Mr. Carson, read them for us, please.
When most solid floats on top of water, the solid turns the water misty. The solid cannot be seen. The liquid is clear. C. The solid cannot be seen. The liquid is clear. D. Some solid sinks to the bottom. The solid turns the water cloudy.
Lovely. Now, what is the name of the process that has happened to solids B and C? The solid cannot be seen. Once you put a solid in liquid and then it disappears, what do you call that process of it going in there, and whether you mix it or don't mix it, it disappears in there? What's happened? What do you call that scientific process? What do you say? Begins with D. Dissolving. Lovely. Well done. Part B now. Mia tries to separate a mixture of solids A and D using a sieve. Mia records observation in table 2. The solids stay in the sieve, the solids go through the sieve A and D. Describe one difference between solids A and D that stops solid A going through the sieve. So what's that going to be? So what is it about A that is different than D? Describe one of the difference between A and D that stops A going through the sieve. So A is what? Go on, Mister.
A is the solid.
They both are, but what's so solid A has much bigger particles than solid. That's it. Okay, so that down. So solid A
Why is he singling?
is made of bigger. Okay. Then solid D. Okay, are we happy with the answer? So we explain. So if solid A stays behind, that means it's particle. The bigger it can't go through the sieve. And solid D did go through, so its particles must be smaller and fit through the gaps. Sieve.
Solid D.
Okay, are we happy with that now?
Yes.
Stop it, full stop at the end and move on to the next question.
Solid B.
Right, question part C now, 4C. Next, Mia puts a teaspoon of solid B into a beaker of vinegar. Then she puts a teaspoon of solid C into another beaker of vinegar. She records the results. So in B, the solid cannot be seen, the liquid is clear. And in C, the mixture bubbles and fizzes. So hang on a second. I haven't asked a question, we're just shouting at C. Which solid has a non-reversible change when mixed with vinegar? Take one box for that is C part 1. And the answer is
C.
C.
A.
Do you see the answer is C?
Do you see that?
What evidence shows the change the solid you chose is non-reversible? What was the evidence?
It's a gas.
What was the evidence?
Can't make
Bubbles and fizzing.
There was bubbles and fizzing.
Bubbles.
And fizzing.
And the mixture fizzes. And
The mixture.
the bubbles and fizzes. Not bubble and squeak.
Fizzy drink. Fizzy drink. Drink.
Full stop.
Fizzy drink.
So I wrote down there were bubbles and fizzing. Oh, but there were bubbles and fizzes. Okay, right. Someone's getting excited and finding that. Oh. The teacher tells Mia the names of the 4 solids. Draw 4 lines to match each solid to its name. So, solid A, B, C, and D. Now, the A, B, C, and D is from what we got from the information from the last couple of tables. So, what is the? Let's have a look. What do you think?
I think A goes to salt. I see.
Okay, let's have a look. Let's go back up here.
Yes, sir.
Hang on a second.
Cross.
Okay, remember, look at B and C. B says here, the solid cannot be seen. Hello. Can we look at B and we'll do B and C first? Because B and C are on the same page. The solid cannot be seen. The liquid is clear. So B would indicate what? Which one of these? One?
Salt.
Well done.
B
C.
salt.
Done, lovely.
Salt and
Next.
vinegar.
Okay, C. The mixture bubbles and fizzes. So which one of those?
The last one.
The last
Will
one.
be called
So that's called bicarbonate of soda. Lovely. So we've done those two.
Soda. I like soda.
These kind of
Or not.
Okay, what's the next one? So now let's go back. Let's go back the page. Quickly check. So A, the solid stays in the sieve. A, the solid stays in the sieve.
flour.
So let's have a look. Why would flour stay in the sieve?
Oh,
my
would it be
God.
coconut?
Out.
Coconut.
It would be
Coconut.
coconut.
And
Coconut.
then these flour.
So we say which one was coconut? A is coconut, yes?
Yeah.
Because it stays in there.
And then bees flour.
Hang on a second.
These bees flowers B.
Okay.
Flowers B.
Okay, hang on a second.
We don't need to.
And the last one's going to be what?
Flower. Let's select.
D is going to be.
Whoa, I didn't know.
Okay, right. Let's change that color.
Hey. Hooray.
So, can we see the lines?
It is.
A is coconut, B is salt, C is bicarbonate soda, and D, I think we need to do D again.
Oh no, I done it. Oh, done it wrong.
Do D
What?
again.
Oh.
So D is flour.
Bees flower.
Lovely.
Lower.
Now, Sandeep, question number 5. Sandeep has some celery. Water can travel up the stem of the celery to the leaves. Give one function of the leaves for the celery plant. Okay, put your hands up if you know what the answer is.
What for?
Okay, we have got a possible of 1, 2,
Steam. Stem.
3. We got actually the examiner has given possible nearly 10 answers.
Oh, 10.
Give one function of the leaves for the celery plant. What does the leaves do? Come on, Zainab.
Oh,
Shh, no.
what the heck?
Shh. Okay, stop screaming at the answers, yeah? Right, go for it, Zainab. What do the leaves do for the plant? So the leaves are the nice, the spread out and they catch the light, give you a clue. What do they do with the light? They turn the light into food. Yeah? So the leaves are used to make food for the plant. The leaves are used for photosynthesis. Yeah? Yeah. Okay. So the leaves are used to okay, we can write here. To make food for the plant. And we can write in brackets on the bottom. Okay, so let's change the color
To
now.
make food for the plants.
Yeah. So the answer is photosynthesize.
Photosynthesize. Photograph.
No, not photograph. You mad about photographs? You are. You know about photographs? Oh, you talk about photosynthesize. That's something else. Photosynthesize. Photosynthesize means capturing sunlight and converting it with CO2 with oxygen in the air. So with CO2 in the air. So we need CO2, carbon dioxide gas, and we need sunlight plus the water from the that comes with the stem. Those three together combined give us sugars. They produce plant. That's called that whole process called photosynthesis. So the plant is the leaf is photosynthesizing. Okay, lovely.
Sir.
What else could we have? Okay, well, so at the moment, what other answers we could write down as well? The by the plant, the leaves do also do what? They absorb sunlight,
Oh, yeah.
or we can say to make produce sugar. Okay, what else do they take in? Carbon dioxide gas. Okay, and they also let water and oxygen escape to store food, to absorb energy from sunlight, to produce chlorophyll, to store waste, to store water. Any one of those answers will give you the mark. Okay, next.
Okay. You on question?
What is that little man?
Is that all done? Okay, next. Let's read the next part. Sandeep puts a stick of celery in a glass of red colored water. When the water reaches the leaves turn red. Sandeep wants to find out if the temperature affects how quickly the water gets to the leaves. Think about an investigation you could do to find out if the temperature affects how quickly the water gets to the leaf. Answer the questions below about your investigation. The variable I will change in my investigation is. So what will you be changing in your investigation? What will you be changing in investigation? You'll be changing what? The what?
Temperature.
Well done.
That's not fair.
What's not fair?
Which one is answer?
Okay. Can you only be the answer?
Oh my god. We're working together.
Yeah. So the experiment is about temperature, so it's going to change the temperature of the water. The temperature of the water. That's what's going to be changed. So the equipment I will use to measure the time it takes for the red water to get to the leaves is what we use to measure the time. What we use?
Stopwatch.
Yeah, simple. Stopwatch.
Stop.
It's a watch that stops.
Stopwatch, or we could write clock, watch, or even electronic timer. That'll do. Any of those answers. Two variables I will keep the same to make my investigation fair are. So how do you keep the investigation fair? What do you do? Keep the what same? Go on.
The celery.
That's right. The length of the celery. Length of celery.
The length
Okay. What else?
of the celery.
Yeah. Length of celery. What else? Gali, you look at the experiment. There's the experiment there. There's the experiment here. Here's the experiment.
The gallery.
What else would you keep the same?
The amount of water.
Oh, what? The red water.
That's right. The volume of water, the amount of water. So I'm writing down here. The be more scientific. The volume. You can write the amount as well. The volume of water.
The whole paper.
What else could you write down?
The
Another possible answer is the size of the glass.
oh,
2 meters.
That could be possible answer. What else?
2 meters.
The number of leaves. Them are the two possible answers. Question number 6. Let's move on. Class 3 on investigating shadows in the playground. It is a bright sunny day. Susie measures the length of Jack's shadow at 9 a.m. Then she measures the length of Jack's shadow at midday. Jack stands at the same position in the playground. Which picture shows Jack's shadow at midday? So for question number 6. So at midday, the sun is nearly directly above your head. So it will be
The sky.
which one of those?
Wait, 0.25 meters.
Okay, 0.25 meters which way? Directly in? In front of him, that one there. Lovely. Okay, that's nice answer.
They're both the same.
Yeah, but one's going that way.
And one's going
One's got
that way.
diagonal.
Yeah, so you can tell from the diagram the sun's going this way.
It's going that
Say, look here, the sun's going this way. And at midday, the sun will be running by here. So the shadow will be directly
Sir,
in front of him.
long time ago, at school, I've been learning about shadows.
Good, good, good.
way.
Yeah, I've learned in your book.
I learned it in.
Okay, right. Yes. We don't need this in the video. Okay, all your personal accounts. Explain why shadow forms on the ground when the sunlight shines on Jack. Okay, Zainab, explain that to me, please. Why do we get a shadow? Shadow occurs because shadow occurs because what happens
The sunlight is.
is being gone. Don't use the word reflected. No.
The sunlight is
Oh, come on, this is a basic concept of science. Go on. Science. No. Okay, let's try this.
The sun's light, I think I know that. Sunlight is
blocking.
It's blocked. Yeah, it's blocked by Jack.
I got that again. I said the sunlight is blocked. I just said it.
Okay, the sunlight can't go through Jack's body, so you get shadow. So shadow occurs when light's being blocked. Okay, because Jack, ask me right, Jack is opaque. I mean, he doesn't allow light to pass through him.
Jack is opaque, sir.
Congratulations.
I did. Jack is opaque.
Okay, right. At 3 p.m., Jack stands in the same place in the playground. Susie measures Jack's shadow again. His shadow has changed position. What movement in space causes Jack's shadow to change position? What's causing his shadow change? What's happening?
The earth is moving.
The earth is moving. Can you be a bit more specific? The earth is
Rotating.
rotating on its axis. The earth
Is rotating.
is rotating
The earth is rotating.
on its
Rotating on its axis.
because the earth turns, the earth moves on its axis, the earth spinning on its axis or rotating, or you can even say the earth revolves. But that's our answer that we can write down now. Any other ones will do.
Axis.
Okay, the class observed Jack's shadow on a sunny day. Tick one box to show why the class should not do the test on a cloudy day.
Because
Okay.
the sun won't come out.
So it'll be cold in the class. No. Because
That
that's
shadow, no, it's difficult.
Now,
to see.
it's difficult to see a shadow on a day there's no sunlight. Yeah, the sun's on a cloudy day.
So I have to test it.
So Jack's shadow is difficult to see. Because Jack's shadow is very dark, no one is making sense. That one is the answer. Susie at the bottom of here. This girl here, Susie. Susie.
Assalamu alaikum.
Okay, Susie has some ideas about shadows. Write down true or false under each idea about the shadows. So, the color of a car's shadow depends on the color of the car, and that is completely
Wrong.
because the shadow doesn't have a color apart from it's like a grey, isn't it?
Black
Yeah,
gray.
black stroke grey or something. I don't think you have black shadows, but normally it's dark
Black
grey.
shadow.
It's a black shadow, really a black shadow.
So you can tell if Jack's eyes are shut by looking at his shadow, and that is completely.
Wrong.
You don't get those kind of details in the shadow.
DJ.
Okay, the shape of the shadow depends on the shape of the object, and that is now.
True.
Okay,
Oh, look, I got it right again.
okay, right. We don't need to have like a big announcement in the lesson that you got it right again and stuff.
Kamal got it.
Remember,
right.
Kamal, the lesson's not about you, Kamal. Yeah. Only light from the shadow. Sorry, only light from the sun causes a shadow.
True.
No,
No.
it's false. Because light from you have light from a torch that can cause a shadow as well.
False.
So that one is
False.
false.
Got it.
Okay, next one is rolling marble. Question number 7.
Rolling marbles. I like that.
Okay, I think Mr. Kamal just loves shouting out that he's got it right.
I got it right. I said.
Congratulations, Mubarak, yeah? John and Ravinder are investigating a marble rolling down a ramp. So here's the two photographs, photograph A and photograph B. That one's got the equipment, and then he releases the marble, then he measures that distance from the bottom. They change the height of the ramp. They measure how far the marble rolls from the bottom of the ramp. They repeat their test with the ramp at different heights. What equipment could be used to measure the height of the ramp? What could they use for measuring the height of the ramp? They could use three possible answers. What would you use to measure the height? Clue. Height is a length. Well done. They could use simply. That's right. Ruler or you say meter stick or meter rule. Okay, what else could they use?
I don't know.
A tape measure. What they use for, like builders use a tape measure. Like
IKEA.
yeah, that's right. So ruler is perfectly good. Meter ruler or meter stick is another possible answer. Okay, you can also write meter rule as well. Okay, next question, part B. Tick one box in each row of the table to show how they used to show how they. Sorry, pardon me. Tick one box in each row of the table to show how they should do the investigation to make sure their test is fair. So, surface of the ramp must be the same, must be different, must be no different. Which one is it?
Must be same.
Height of the ramp must be
Same.
no, because that's what you're doing. The experiment's about height. How can you keep the height the same? Size of the marble should be.
Same.
Mass of the marble should be there.
Make no difference.
No, it doesn't make a difference. Of course it does.
I'm guessing.
We're not supposed to be guessing. We're doing science. It's not called yeah. We're not doing bingo.
Bingo. What do you think bingo?
Done.
Yep.
Okay, now John and Ravinder must decide. That's first part. What height they should put the ramp at. Look at this photograph. John says this ramp is too steep. It will not give good results. Explain why the ramp in photograph C is too steep to get good results. So, go on.
Well, because it's like standing up and if you like.
So give me a bit more explanation.
And if you
So the marble might not even
round.
touch the ramp. It's so steep, the marble might just fall down.
Because it's like straight and then
Yeah.
it's gonna go like.
So the marble might just fall to the floor without actually rolling on the ramp, yeah? So that's the thing.
Supposed to curve it a bit.
Okay.
Curvy, worvy.
So the marble might just fall off the ramp or fall straight down without even touching the ramp. So any of those wording is good. So the marble drop very quickly and might bounce. The marble might not touch the ramp. The marble might break. It will just fall straight down. The marble will fall off the ramp. Okay, lovely. Next question. Ravinder.
After this question,
Ravinder plots a graph to show the results. Draw a cross on the graph to show the distance the marble would roll if the ramp was 0 centimeters high.
Not.
So where would it be?
Maybe flat.
If it's 0 centimeters high, the marble would be 0, 0.
So done this at school again.
Okay. So Justin lights a candle. When a candle burns, a non-reversible change happens. Okay. Complete the table to show if the observation is evidence of a reversible or non-reversible change. Tick one box in each row. The wax melts. If the wax melts, this is evidence of what?
A non-reversible change.
No. If something
This
melts,
is the evidence of non-reversible change.
this is evidence of a reversible change. If something melts, you can cool it and it will go back to being solid again. So that one it actually is reversible. Next one, smoke is given off. When smoke is given off, what's that? Does that tell us it's reversible or irreversible?
Irreversible.
Absolutely irreversible. Because what's happened? We've had a chemical change, and that's what's called irreversible. Justine has candles of different heights but the same width. She wants to burn them all down to a height of 1 centimeter. Describe the relationship between the height of the candle and the time it takes to burn down to 1 centimeter. So, what do we say here? What is the relationship here?
The tallest will take the longest.
So give me like, so the taller the candle,
The
the longer it takes to burn. Lovely, that's the answer. So the taller the candle, the longer okay so we can say here, right, hang on a second. Hang on.
Could you put longer?
The longer the time it takes to burn down to 1 centimeter. Now, if you look in the text there, the key word have been underlined height, and this is the height, the higher. This here, the taller is indication by the height. And time, we mentioned time, and burn, we mentioned burn. So they've mentioned height, time, and burn, and we mentioned all those three items in our answer. Okay. Nearly finished, baby.
Last question. This one's
Justin has 3 new candles. They are the same height but have different widths. Justin wants to find out if the width of the candle affects the time it takes to burn down. She times how long it takes for each candle to burn down to 1 centimeter. Candle A is the solid line. Candle B is the dotted line but with big gaps. And candle C is the dotted line with small gap. So candle C burnt down the quickest. How do we know that? Because it took the least, no, if you look over here,
It took the least small.
the least amount of time. This is the time taken.
Oh.
Okay, candle C. How many minutes did it take candle C to burn down to 4 centimeters? So give me one moment while I get this. Where's 4 centimeters? 4 centimeters is where?
right there.
Right there.
3 centimeters.
So we're looking at candle C.
Oh, that one. The dotted line one. Yeah, 3 centimeters.
Okay, are we looking at, has everybody done that? What I've just done, have you done that?
No.
Yepo.
Yep. Oh.
Yep, we did.
So, I mean, you don't need to do a square search, but what I've done there, okay, let's make it a bit bigger so it kind of looks nice.
Up to 4 centimeters.
Yeah, man.
I didn't.
Hang on a second.
You can do it.
Here we go. So if you look over here, we got our pen selected now. So we got here.
No one.
So here's 4 centimeters. So we go across. We touch the graph C, which is the dotted one here, and then we come which way? Straight down. And it comes to roughly what? What would you say roughly that time was? That's 20. That's 25. That's 40.
22.
22.
About yeah, 22. 22 is lovely. About 22 is good.
22.
Goes like. What about 21?
Now let me tell you what the examiner will allow. The examiner will allow for that question
25.
anything from 21 to 26.
Yay! Okay, right.
Okay, so on my graph it looks like 22. So anything between 21 to 26, the examiner will give you the mark. So there's the
One more question.
okay. One more question.
Yeah.
About this.
Yeah.
Your line.
Only the reading thingy.
Okay, says that Justin has another candle. It is thinner than candle C, but it has the same height. Draw a line in the graph to show how quickly the new candle will burn down to 1 centimeter. Okay, so that's question D. Give me one moment. Let's have a look at that. How about we do that?
Push your answer.
So everybody have a go at that question. So where do you think it'll be? I'm going to draw my line, but before I draw my line, I want you to have a go at yours. So everybody, get back to this graph here and draw your line first. Are we in the lesson? He just told you to draw a line for this candle, which is thinner than candle C. So draw a line like the way they've drawn lines. Okay, off you go, Mr. Ilyas. Wakey. Let's go.
Well, what do we represent the line?
So now, don't forget this first line here. This first line here was nice and it was the thick candle, the thickest candle. This was the thinner candle. That was the thinnest candle. Now we're gonna have one even thinner than that. So where will that line be? Will it be steeper, more shallow? Will it be for you to think? I want you to do it first before I put my answer on there. Off you go. Everybody have a go. Get a ruler. Grab a ruler. Yes.
Can I do it in pencil first?
You could do it in pencil first and then in paintbrush after. It's up to you. I'm gonna pause the video. Okay, folks. Right. Let's have a go at this line. Some of you have had a go. Now the line should start first of all at the same height. Okay, so it says it should start at 10 centimeters. Now it should finish before the time of this line C. Okay, so this one finished at roughly around about 20, 25, 27. So I'm gonna do my line now. Here we go. And I'm gonna anything below here, you can draw a line. You can be here, any line below this line. So I'm just going to do mine right about here.
I'm going to do mine 20 because I will take away 20.
Okay? So I'll do mine there.
So like this?
Anything below that line.
You all take away 20.
Well, I can't see from here really. But I just show you anything below the dotted line. So I've got mine is a dark red line. And that is the answer. And that is the end of the
So it's just below.
No, it's not. Oh, yeah, it is. Yay.
So this, what's this
Oh,
thing
yeah.
behind
Oh,
this
yeah.
and practice stuff?